Hello, good morning, good afternoon, and good evening po. I am Janelle Cortez from BSARCH 2-3, and today I'm going to be talking about patterns and numbers in nature from the subject Math in the Modern World. So you might be asking, nature has nothing to do with math, right? Actually, according to Galileo Galilei, the laws of nature are written by the hand of God in the language of mathematics. According here in the lecture, mathematics serves as the universal system for organizing, identifying, and predicting the highly structured behaviors of the natural world. Far from being a collection of random layouts, the universe relies on strict geometric frameworks, numerical sequences, and chemical reactions designed to maximize efficiency, conserve energy, and ensure structural strength. There are so many examples that shows math in nature, like numbers and the patterns in animals and plants, and anything you can think of that nature has shown, like rock patterns. Yeah, and examples are like the Fibonacci spirals and packing that you can see in pineapples or pine cones, or how sunflower seeds are formed, like obviously in a pattern like this. And examples are the Turing pigmentation patterns, like in zebras, like this, or the leopard spots, things like that. So what I've chosen to show for an example are the Turing pigmentation patterns and the reflection symmetry. So Turing pigmentation patterns and the reflection symmetry is what I'm gonna be showing here in this video as an example. So as you can see from the previous clips of as examples of Turing pigmentation patterns, in the lecture it only showed animals with patterns like zebras, cheetahs, or pufferfish. And I did my research, and you can also see it in plants, like what is shown from the previous clips, or here the pictures around. As an explanation, these patterns are dictated by chemical reaction diffusion equations, where two chemicals interact and spread through tissue to create distinct visual layouts, as you can see here in the shown pictures of plants that I went and videotaped around my home. These plants can be shown to have like green and yellow spots, and then a pattern of like dark color, and then a pinkish, hot pinkish red type, and then some patterns where it's green and yellow streaks, like that. And then the plant espada, called espada, has patterns like only seen in many types of animals too. It has that type of pattern, but not really because it's a plant. But it can be seen here that there is a pattern clearly caused by the chemicals interacting with each other and forming these visual layouts that you can see. The next video example is a butterfly. Actually stumbled upon it as I was video filming the plants, and I was clearly very lucky that I get to see a butterfly and it's flying all around me. So it can be roughly seen, but here I paused the video and you can see that there is a symmetry that it can be seen. So it's called the bilateral symmetry. Bi meaning like two. Its symmetry organizes biological life into balanced proportions across a central point or a dividing axis. And an example also here in the lecture is a butterfly. And it said here, these organisms display strict bilateral symmetry, where the left half perfectly mirrors the right half to aid in stable flight balance or to attract specific insect pollinators. Ooh, okay. So it also applies to plants, to these bilateral symmetry. And another example or explanation here is the reflection symmetry, which I've mentioned. It is also called mirror symmetry or line symmetry. It is made with a line going through an object which divides it into two pieces that are mirror images of each other. This is often termed as bilateral symmetry, as it divides the object into two mirror images. Like this butterfly that I've captured, it shows patterns reflecting the other wing it has. So now the question that we mentioned earlier in the introduction, nature has nothing to do with math. Is that right? No. And that is the answer that we have come to after discussing the many examples and the explanations we had earlier. How can it help us appreciate more or deepen our understanding of math in nature? So this these brief examples that I've shown can be seen in many more outside our homes that we can see while walking or like running, riding a vehicle. You can see it all around us, not only in structures that was made and designed by a human, but these patterns in nature that can be associated, which is also associated rather in mathematics, which is the patterns and numbers in it, can also influence how we think, how we apply it in our activities. And as an architecture student, it also applies to me in how I come up with designs that clearly shows the mathematics is used in everyday life. Thank you and goodbye.